Download this code from codegive.com, link in the description below. Refresh tokens and JWTs, a comprehensive guide with code examples. JSON web tokens, JWTs, are a popular choice for securing APIs and applications. They are compact, self-contained, and easily verifiable. However, a key challenge with JWTs is that they are typically short-lived to minimize the impact of a compromised token. This necessitates a mechanism to obtain new JWTs without requiring the user to re-authenticate constantly. This is where refresh tokens come in. This tutorial will cover the following. 1. Understanding JWTs and refresh tokens. 2. Why use refresh tokens. 3. The refresh token flow. 4. Storing refresh tokens. 5. Implementing refresh tokens in node.js with Express. 6. Security considerations. 7. Alternative approaches. 8. Conclusion. 1. Understanding JWTs and refresh tokens. JSON web token, JWT is standard for creating data with optional signature and / or encryption whose payload holds JSON that asserts a number of claims. JWTs are typically used for authorization. A JWT contains 3 parts, separated by dots. Header * specifies the algorithm and token type. Payload * contains the claims, information about the user, roles, permissions, etc. Claims can be registered, example ISS, sub, AUD, EXP, IAT, public, or private. Signature * created by encrypting the encoded header and payload using a secret key or a public/private key pair. This ensures the token's integrity. Example JWT. Refresh token *, a long-lived token that is used exclusively to obtain new access tokens, JWTs. It's not used to directly access resources. Since refresh tokens can live longer, they should be stored securely, example in a database. They can be revoked, allowing you to invalidate a user's session even if the JWT is still valid. 2. Why use refresh tokens? Enhanced security * short-lived JWTs reduce the window of opportunity for an attacker to use a compromised token. Improved user experience * users don't have to re-enter their credentials frequently. The refresh token handles the renewal of access tokens seamlessly in the background. Session management * refresh tokens provide a mechanism to explicitly terminate a user's session by revoking the refresh token. This is useful for scenarios like password resets or account lockouts. Scalability * refresh tokens can be stored and managed centrally, allowing for easier scaling of authentication services. 3. The refresh token flow. The typical refresh token flow looks like this. 1. User authentication * the user authenticates with their credentials, username/password. 2. Issue access token and refresh token * the server verifies the credentials. If valid, it issues both an access token, JWT, and a refresh token. 3. Store refresh token * the refresh token is securely stored, usually in a database, associated with the user. 4. Return tokens to client * the access token and refresh token are sent to the client. 5. Client uses access token * the client uses the access token to make API requests. 6. Access token expires * the access token expires. 7. Client requests new access token * the client sends the refresh token to a dedicated refresh endpoint. 8. Server validates refresh token * the server verifies the refresh token. Is it valid, not expired? Is it associated with a valid user? Has it not been revoked? 9. Issue new access token, and optionally a new refresh token. If the refresh token is valid, the server issues a new access token, JWT, and optionally a new refresh token. Rotating refresh tokens is a security best practice. 10. Return new access token, and new refresh token. The new tokens are sent back to the client. 11. Client updates tokens *. The client replaces the old access token and refresh token with the new ones. 12. Repeat steps 5 to 11 as needed. 4. Storing refresh tokens. Storing refresh tokens securely is crucial. Here are some options. Database *. This is the most common and recommended approach. Use a robust database like PostgreSQL, MySQL, MongoDB, etc. Store the refresh token, user ID, expiration date, and revocation status. Index the refresh token column for efficient lookups. Redis *. An in-memory data store. Redis offers very fast lookups, making it suitable for high-performance applications. Remember that Redis is volatile, so data persistence is important. Token binding *. A more advanced approach that binds the refresh token to a specific client device or browser. This mitigates the risk of refresh token theft. Requires careful implementation and support from the client. For the following code example, we'll use a database. Specifically, we'll abstract it for simplicity. 5. Implementing refresh tokens in node.js with Express. Here's a basic example using node.js, Express, and the json wetoken library. Explanation ***. Dependencies *** Express, json wetoken, bcrypt, uuid are used. Environment variables *** It's best practice to store secrets like access_token_secret and refresh_token_secret in environment variables. Use the dotenv library, npm install dotenv, to load them from a .env file. Generate access token, user, generates a short-lived JWT. The expires in option specifies the token's expiration time, example 15m for 15 minutes. Generate refresh token, user, generates a long-lived refresh token. It's signed with a different secret key than the access token. Authenticate token, REQ, res, next, middleware function that verifies the JWT in the authorization header. If the token is valid, it adds the user information to the REQ user object. */login root authenticates the user, generates both access and refresh tokens, stores the refresh token, in memory in this simplified example, and sends both tokens back to the client. */token root, refresh token endpoint receives the refresh token, verifies its validity, and issues a new access token, and optionally a new refresh token. */logout root revokes the refresh token by removing it from the refresh tokens array, in memory. In a real application, this would update the revoked status in the database. */protected root an example root that is protected by the authenticate token middleware. Only authenticated users with a valid access token can access this root. Important considerations and enhancements replace in-memory storage the example uses an in-memory refresh tokens array. This is not suitable for production. Use a database to store refresh tokens securely. Error handling implement proper error handling and logging throughout the application. Input validation validate all user input to prevent injection attacks and other vulnerabilities. Rate limiting implement rate limiting on the /token endpoint to prevent abuse. *HTTPS*. Always use HTTPS to protect sensitive data in transit. *refresh token rotation. * Generate a new refresh token each time a user requests a new access token. This is a security best practice that reduces the risk of refresh token theft. Revoke the old refresh token. *Token revocation. * Provide a mechanism for users to revoke their refresh tokens, example from a user profile page. *Secure storage of secrets. * Never hardcode secret keys directly into the code. Use environment variables or a secrets management solution. 6. Security considerations. Protect refresh tokens. Refresh tokens are sensitive and should be stored securely, encrypted at rest. Refresh token rotation. As mentioned earlier, rotating refresh tokens mitigates the risk of a compromised token being used indefinitely. Limit refresh token lifetime. Even though refresh tokens are long-lived compared to access tokens, they should still have an expiration date. Revocation. Implement a mechanism to revoke refresh tokens, example when a user changes their password. Monitor for suspicious activity. Monitor the /token endpoint for unusual activity, such as a large number of refresh requests from the same IP address. Token binding. Client-side token binding techniques like mutual TLS can further secure refresh tokens by binding them to a specific client device. 7. Alternative approaches. OAuth 2.0 and OpenID Connect, OIDC. These are well-established authentication and authorization protocols that provide more comprehensive features than a simple JWT-based refresh token implementation. Consider using them for complex applications. Stateless refresh tokens, self-referential tokens. These tokens contain all the necessary information to validate them without needing to consult a database. They can be implemented using techniques like encrypting the user ID and other relevant data within the refresh token itself. This reduces database load but can make revocation more complex. 8. Conclusion. Refresh tokens are an essential part of a secure and user-friendly JWT-based authentication system. By using short-lived JWTs and long-lived, securely stored refresh tokens, you can minimize the impact of compromised tokens and provide a seamless experience for your users. Remember to implement proper security measures, such as refresh token rotation, revocation, and monitoring, to protect your application and your users' data. This comprehensive guide provides a strong foundation for building a robust refresh token implementation in your node.js applications. Always consult the official documentation for the libraries and frameworks you are using for the most up-to-date information and security recommendations.